Hi guys, today we're looking at a heat pump. Our learning intentions for today are to be able to explain how a heat pump works and draw a diagram of a heat pump. A heat pump is a device that transfers energy from a cooler region to a warmer region. For example, a heat pump is how we remove hot air from the fridge, so we remove the heat from inside the fridge and we deposit it outside the fridge. To remove heat from a fridge, work must be done. Heat naturally travels from a hot place to a cold place. So when we're trying to remove heat from an object, we must do work for this to occur. A heat pump consists of a closed circuit that has a liquid called a coolant in it. Let's look at this following diagram of your fridge freezer. So here you can see that your heat pump is a closed circuit tube that goes inside the freezer and outside the freezer at the back. Let's look at how this device removes heat from your fridge or freezer. So the heat pump contains a liquid that has a high latent heat of vaporization and a low boiling point. So in this closed circuit, there is a coolant. The coolant has a high specific latent heat of vaporization. This means it stores a lot of energy before it changes state. And it has a low boiling point. This means that the coolant changes state at a very, very low temperature. This liquid is pumped around this circuit. To use this liquid to remove heat from the freezer, the heat pump contains two devices. It contains an expansion valve and it contains a compressor. Okay, let's look at how the heat pump removes heat from inside the freezer. We have our coolant in our closed circuit. As the coolant, which is in liquid form, enters the expansion valve, the pressure drops and this liquid vaporizes. So your liquid becomes a gas and it travels around inside the back of your fridge. As it does this, it removes heat from inside the fridge in its latent heat. So the vapor takes energy from the fridge as latent heat. Then the vapor goes through a compressor. The compressor has high pressure, so it forces this vapor to change back into a liquid. So it pushes the molecules closer together. It has high pressure. As the molecules move closer together again, they change back into a liquid form. And this latent heat that they had between the molecules, all of that potential energy that they had, is deposited at the back of the fridge, i.e. the heat is removed from the fridge. This is why if you feel the back of a fridge, it is always very warm, because your liquid is depositing this latent heat, i.e. it is depositing the energy from the fridge. This process then repeats itself. Let's look at this again. Here is our heat pump. Our heat pump contains three things. It contains a coolant, which is a liquid that has a high latent heat of vaporization. and a low boiling point. This liquid travels through your closed circuit. The liquid reaches an expansion valve. Here, the pressure drops, and the liquid changes into a gas. The gas travels through the closed circuit at the back of the fridge. Here, this gas takes energy from the fridge and holds it in its Bond's latent heat. So it can hold lots of potential energy here because it is a high specific latent heat of vaporization. So the vapor takes lots of energy and holds it as latent heat, i.e. holds it as potential energy between the bonds. The vapor then continues to the back of the fridge, so outside the fridge, and it goes through a compressor. The compressor increases the pressure and forces this gas to change back into a liquid, i.e. the molecules are forced closer together again. As the molecules are forced closer together again, it loses all of that latent heat energy, and that is deposited at the back of the fridge. We then have a liquid in your closed circuit again, and the process continues. The liquid goes through the expansion valve, changes into a gas. The gas takes in loads of energy from the fridge and stores it in its potential energy. So it stores it between its bonds. It goes through a compressor. The compressor wrings out the vapor, changes it into a liquid, and deposits the latent heat at the back of the fridge.